Here are some melting point of objects. Sodium chloride is 800.7 degrees Celsius. Iron is 1538 degrees Celsius. Ethanol is minus 114.5 degrees Celsius. On the other hand, boiling point of the same objects, sodium chloride is 1465 degrees Celsius. Iron is 2862 degrees Celsius. Ethanol is 78.5 degrees Celsius. But if you look at water, its melting point is 0 degrees Celsius and boiling point 100 degrees Celsius. Is it a coincidence that water has such perfect melting point and boiling point, or is there something more to it? To answer that, let me ask you a question. How do we measure temperature? Of course, using a thermometer. But what is a thermometer and how does it measure temperature? Let's find out. A thermometer is something which senses temperature. Any object that is sensitive to temperature can be used as a thermometer. It may change its volume with change in temperature, or its resistance, or change its color. Any physical or chemical change with change in temperature can be helpful to measure the temperature. Okay, now we know that any material changes with temperature can be used as a thermometer. But just the change is not enough. We need to know what does that change indicate. That is, we need to calibrate the thermometer. How do we do that? In order to make sure that the calibrations are universal, we have decided upon two fixed points. These points have been decided by consensus. The points are the melting of pure ice, which is considered as a 0, and boiling of pure water, which is considered as 100. In order to calibrate your thermometer, you first immerse it in pure melting ice. Then you wait for your physical quality to change, mark that point as 0. Then later you immerse your thermometer in boiling water. You wait for the change in your physical quality and you mark that point as 100. Divide the region between 0 and 100 in 100 equal parts. And that is how you will calibrate a thermometer. Range of an object is the difference between the lowest temperature the thermometer can measure and the highest temperature the thermometer can measure. In the given case, thermometer A can measure from 0 to 100 degrees. So the difference is 100 minus 0, which is 100. It has a range of 100. On the other hand, thermometer B can measure from minus 10 to 120. So 120 minus 10 is 130. Thermometer B has a range of 130. Hence, thermometer B has the higher range. An ideal thermometer is supposed to have infinite range. Sensitivity of a thermometer is basically how much change does the thermometer show with 1 degree change in temperature. In the given case, thermometer A shows lesser change with same change in temperature compared to thermometer B. Hence, thermometer B is more sensitive. Responsiveness tells you how quick the thermometer is to change in temperature. In our example, when both the thermometer A and B are immersed into an object, thermometer B immediately shows the change in temperature, while thermometer A takes some amount of time, and hence thermometer B is more responsive compared to thermometer A. Linearity means that with 1 degree change in temperature, the thermometer would show same amount of change every time. For the example here, thermometer A and thermometer B, for first degree rise in temperature, the change is as. For the second degree rise in temperature, thermometer A increases larger compared to previous time, while thermometer B increases with the same amount. Hence, thermometer B is linear and A is not. As the name suggests, a liquid in glass thermometer consists of a glass tube filled with a liquid which changes its volume with change in temperature. The liquid is filled in the bulb at the bottom of the thermometer, while it is allowed to rise up in the capillary. The liquid generally filled is alcohol or mercury. A thermistor is a semiconductor device which changes its resistance with change in temperature. A thermistor has an advantage that it can be connected into a computer and hence making it easier to collect information. A thermocouple. A thermocouple consists of two metals connected at both the ends. When one end is heated and the other end is cooled, you see that a certain amount of voltage is generated. This can be used as a thermometer. A thermocouple is a very good thermometer because it has a large range, is responsive and has high sensitivity, and it can be connected to a computer or a data logger to gather the information very quickly. And with this, we conclude our series on thermal physics.